reactants in your products, if they're all gases, then instead of using concentrations, we will be using what? Partial pressures. I'll just do this on a new page. So if your reactants and products are gases, instead of using concentrations, we use partial pressures, right? Let's take an example of a reaction where you have A plus B giving A, just be unimolecular, A giving B plus C. This is a gas, gas, and gas. In this case, we will not be using concentrations. In this case, we will be using partial pressures. Let's talk about at time 0, right? So I'll call this the initial partial pressure of A, right? ATM. This guy, however, because initially the product nahi hota, so this will be 0 ATM. This will be 0 ATM. Let's talk about at time t, right? Any value. Let me say this was X ATM. This was also X ATM. So this will be initial minus X ATM, right? So because obviously these are gases, the reactant and the products are gases, so that's why we're using what? Partial pressures, okay? Now you know that the total pressure will basically be equal to partial pressure of A plus partial pressure of B plus partial pressure of C, right? So can I say my total pressure would be partial pressure of A kya hai? Initial minus X, partial pressure of B is plus X plus X. So can I say total pressure basically would be what? It would be Pi plus X, right? Because it's going to be Pi minus X plus 2X, so it will be Pi plus X. And I can make X the subject, so it will be total pressure minus the initial pressure of A is equals to X, because over here I'm only concerned with A, right? Just like we were concerned with the reactant concentration, here we're only concerned with the reactant's partial pressure, okay? So I can say that PT minus the initial partial pressure of the reactant is equals to X, okay? Now, you know that the initial, one second. Yeah, so this will be equals to X. Now you substitute X. You substitute X. You know that partial pressure of A is equals to Pi minus X, right? So I can substitute the value of X. It will be Pi minus PT minus Pi, right? So I can say that the partial pressure of A at time t would be equals to 2Pi minus PT, right? I can simplify this and that will be 2Pi minus PT. Okay. And now I can go back to the same formula that I used for concentrations, but rather than using the concentrations, I will be using what? The partial pressure, right? So I can go back to that formula that we had, which was K is equals to 2.303 upon T log R naught upon R, right? But instead of concentration R naught and R, this time I will be using what? 2.303 upon T, yes, where T basically is T2 minus T1, where my T2 is time T, T1 is 0. So technically it is T, so I don't really have to put T2 minus T1, right? So this is T. And this will not be concentration, but this will be Pi, which is your initial partial pressure at T0. And this will be what? PA, which will be your partial pressure at T time T, right? So basically this will be what? This will be K is equals to 2.303 upon T times log of initial pressure upon pressure at time T, okay? And you know that partial pressure of A at time T was what? 2Pi minus PT. So I can put what here? 2Pi minus PT, right? So this will be K is equals to 2.303 upon T times log of initial pressure upon 2 pi minus Pt, right? This will be in case of having what? Gases as reactants and products. Instead of using concentrations, we will be using what? We will be using partial pressures. Okay. Now we just have a little bit of this chapter left, and I wish I could have taken a longer class today, but